So, good afternoon, everybody. My name is Brandon Weaver. I'm a DevOps manager at Purchase Stream. I've been here about 3 years. I've been working on what's now called DevOps for about 17 years. It started out as software configuration management. It moved into build and release, and now it's called DevOps. And every time they change the title, we end up with more work to do. So, I actually didn't think there would be this many people here because I thought everybody was like, test automation, yeah, we should do that. We do that. It's awesome. But there's actually quite a few people here, and so what I wanted to talk about was how you get test automation going, the reasons for doing it, and how it all fits together. So, manual testing is a very time-consuming task. I don't think that many people really realize how much they do can actually be automated. And I actually worked for a guy many years ago, and we always had this argument that everything can't be automated. But actually everything can be automated, it's whether it's worth automating it or not. So manual testing is actually very much worth automating. The parts that are very repeatable, the parts that you can optimize, make them go faster. It allows you to test faster, and getting it through your entire stack gives you a better overall sense of your quality as you move further down the line. It also helps you fail much earlier than you would if you went through the whole process, you get a release out, and you find out, I did this completely wrong, and so now you've got to go all the way back to the beginning and start over again. So just a quick example. This little class here, and I kind of used some code that was available on the internet, but I just wanted to do a quick example of when you sit down and you write your code. If you're writing your test as you write your code, it takes much less time to do it as you're writing your code than it does to do it afterward. It additionally is way quicker than doing it manually. So in this case, the 7 tests took 5 minutes to write, they take 1 minute to execute. Testing each one of them manually takes 2 minutes. So within 5 runs, you've already gotten a return on the time you invested on the front end to do your testing, to automate it and get that repetition out of the way. And I was talking about how much more expensive it is the further you go down through the process. And so it's not pretty, but I put this together to kind of illustrate that. When you catch the bugs in development, you've only got one person involved. And that person spends however amount of time it takes to find that bug and fix it really quick, and they move on. But as you get further away, QA tests it. Well, now you've got 2 people involved. QA's found the bug, they got to talk to the developer, and you go back to the top. So it's not exactly 4 times, but when you actually get to your live code running in your operations or at your end customer, you end up getting all these people involved, and you're spending at least probably 4 times the amount of time, resources to fix one bug that made it all the way through. So you should try to catch your test automation as quickly as possible. Use test automation to catch your bugs as quickly as possible and as early in the process as possible. That time spent on the front end is way more valuable than catching it on the back end. Automated testing allows you to fail early. Failing tests should actually stop the flow of the software from the developer to the end result. You should never allow your code to continue through the process with failing tests because, as I mentioned, the further you get in the process, the more expensive it is. It's an opportunity for development QA to communicate and work together. Obviously, in the case where it's a unit test and the developer is actually caught doing the unit test and they caught that, it's only them involved. But if it gets to QA, the 2 of them can work together and they actually can have a better plan of how do we automate this to test this better? What is the goal of this feature? What are the touch points? How do I get these to work together? And lastly, failures after release. On top of having more people involved, they're always disruptive because somebody is screaming, this is broken. They come back and they want it fixed immediately. and you've got all these other people involved. So failing early is very important, and that's one of the reasons that test automation is so important. So what does it look like as you get through the process? For DevOps, the DevOps team, there's actually a lot of pieces. It's not just test automation. The build automation is part of this, the test automation execution, the reporting, the setup, and the actual deployment itself. All of these are part of the test automation process. You can't do the test automation if you don't have the build automation. You can't do the test automation if you don't have the environment set up. So DevOps' role in all of this is to put all these pieces together and be an enabler for doing test automation. Also part of that, DevOps is responsible for promotion of the code. So you'll want to get a process in place where your test automation happens, you decide this is good or bad, we should automatically promote this to the next level. So it's not just trying to prevent problems when they get to the end result, you want to prevent problems all along the way. You should never promote code that's not working to QA, because then QA is spending time testing something that you know is bad. So DevOps should also automate the deployment and the environment build so that they can have these test beds where they can spin them up, they can do the testing, and tear them back down very quickly. The developer's role in this process is the unit tests. And I'm going to use terminology, and everybody describes all kinds of testing in totally different ways. I tried to explain in my slides what I see these as. So we can have some discussions about what these really are if you would like. Unit tests are the first chance to identify failures. They should be very small tests. They're really at like the method level. I have a method, it adds two numbers, does it return the correct result? Can I break it by giving it a number that's longer than what is expected? Can I break it by throwing a string at it? So these are the types of things that you should be testing with your unit tests. In addition, it gives you some measurable coverage of the code. How many tests are we running against these particular pieces of the code? Integration tests, I think people call these a lot of different things. To me, these are tests with not only with other systems in your own software, but your third-party systems, your databases, your RabbitMQ messaging bus, whatever you have there. And what you want to actually do is to avoid those in your unit tests, because your unit tests should run during the build. It should happen very quickly and be over. With integration tests, you actually have the setup cost of enabling the databases, your message bus, and all these other systems that you need to test with. So that's why I break these down into unit tests and integration tests. And then quality assurance or quality engineering, and this is kind of another area where automated testing is changing. People are calling it different things depending on how much automation you have, how early in the process you are. There's things like end-to-end tests that test the API, the back end, the dependencies all the way from one side of the software to the other. UI tests, kind of self-explanatory. It also actually ends up testing your back end if you've got proper separation between the two, but it's not necessarily intended to test the back end, it's to test the front end that it works with the back end the correct way. And then performance tests, they stress the system and try to break it. Security testing, this is something at least relatively new to us. I think that a lot of people do their security scanning and it's a manual process, and they do it late. They do it very late in the game. So what we've actually tried to do is get that security scanning up front. We try to do it much more quickly, much earlier in the process, and we take the results and we look for certain things that are critical issues, critical failures that we need to get in order for the security to take a closer look at them. You're never going to completely automate the security scanning because a lot of these tools are just not intended for automation, and it also requires subjective review of the results. So what you're trying to do there is just flag for things that you know are going to be a problem. So this is kind of how I've always looked at the progression of getting from one end to the other. And I've done this several times, several different stops that I've been at. And as was mentioned in the keynote, you want to take these off in little bite-sized chunks that you can manage at a time. When you walk in and you don't have any standardized build tools, you've got 3 or 4 different things working different ways. You have tools such as Bash or command line that are doing the builds. It actually makes it more brittle. So what you want to standardize on a build tool, and it doesn't matter which one you choose, other than the tool works for you. So continuous integration tool, Jenkins, TeamCity, Bamboo, TFS. Again, it kind of depends on what code you're trying to build, what your build tools are, and those types of things. But you want to be able to repeat the build using your standardized build tools and report on the results of that. Enforce standards on fail and skip tests. And this is always the hardest one because there's always a debate. What should we consider a failure, right? My definition of a failure is if any test fails, it's a failure. If more than 10% of the tests are skipped, it's also a failure because somebody could be trying to game the system. Hey, you know what? I know this test doesn't work. I wrote it so I could get it through code review. Let me just turn it off so that nobody notices. So, but you have to come up with standards and you have to enforce those standards. It doesn't do any good to come up with standards and then ignore them. And then implement automated runs for all your automated tests. This is everything from your security tests, unit tests, end-to-end tests, everything. Standardize your packaging and make it the installation automation capable. You're never going to be able to effectively run your tests if you can't automatically deploy your software. Same thing for environment automation. You've got to have that environment to do your installation. You have to get your environment automated. And it doesn't necessarily have to be built from scratch. There's lots of different opportunities there to get some things up and going quickly. You can use snapshots, whatever works for you. Reiterizing, automate deployment. It should be zero touch. You should be able to have a job in Jenkins that you execute that will deploy your entire environment, from environment to your software to any tools you need for your testing to prepare for that automation run. And then report your metrics. This goes back to what's failed, what's not, how are we doing, what's the quality of the code. Development, and this is not going to be popular with development managers. Test failures take precedence. All those new features don't mean much if your current code doesn't work. Start small. All new code, write unit tests. Make sure you're ensuring proper coverage of your code as you go along. This will help you start from zero to get your code coverage up in order to get to the next level. Same thing with defects. Every time you get a new defect, you write a new unit test to make sure that that defect can't crawl back into the code without noticing. When you refactor code, produce unit tests. And this one's probably a little bit harder and a little bit bigger. But just doing the new code and the defect code will never get you all the way there. So at some point you have to take that time to do the unit tests when you refactor the code. Try to get to 100% code coverage. Almost nobody ever gets there. They get close, they do a pretty good job, but it's way better than having 10% code coverage. Work on your integration test after your unit test. Your unit tests are your first line of defense to getting bugs out of your code. You still need to do your integration tests, but they just have to come after unit tests. For the QA and quality assurance departments, you want to implement automated tests for new functionality, as it happens where appropriate. So not everything is going to get an automated QA test. If you have sufficient coverage on your unit tests, there may not be a situation where you need to actually implement a QA test to test that same batch of code. Work with development, starting at design. When development sits down and says, I'm going to write this new feature, QA should be right there saying, how are you going to implement this? What do I expect from the code? At that time, they can write your test cases, and then they can actually do the automation. They don't even have to have working code yet. They can go ahead and do this automation, and then when development finishes the code, they sit down, they run it, and they revise it as needed. Write tests for existing test cases as time allows. As I mentioned before, you're never going to get it all in. You're never going to stop long enough to do it all at one time. You start with your new code, and you work backwards as defects and all those types of things come up, refactored code. Identify the key tests to automate first. So if you have areas where you know we have frequent problems with bugs in this area, you should try to automate those first. And the areas with broadest exposure across many parts of the software are critical. So if you have a piece of code that covers 4 or 5 different components, that's probably another good place to start, because if those 4 or 5 different components don't work with that one piece of code, you're going to break a lot more than if you're just testing one little piece. For security, identify and implement tools that can be automated if possible. Again, security, a lot of that has been rooted in manual processes and manual scanning and review, and it absolutely makes sense. There's certain security things that you just can't, and of course I said you can automate anything. There are certain things you can't automate, and one is making a judgment call. Does this matter? Identify thresholds to trigger automation failures. So when you put all these pieces together, what you end up with for CI, you have DevOps they're doing the build automation, they're setting up the environment, they're deploying it, they're running the tests, and they're reporting back. Feeding into that, you have development giving unit tests and integration tests to make sure that all of those pieces work. And then lastly, you have QA doing the end-to-end test, the performance testing, and the UI testing. And this is for CI, and we don't have security here. And the reason for that is that it's even though you want to do it more often, it's not something you want to do every time you build. Every time you build, you want to make sure your unit tests work and your integration tests work. Because if either of those fail, there's really no point in going forward to the next stage. You want to make sure that QA, end-to-end tests, performance testing, and UI tests just UI tests. Those are taking place on your CI build. And actually, see, I left a box off here, and I apologize. But the end-to-end tests and the UI tests take place in CI. Those are going to be longer tests. They're going to take on the order of twice as long or 3 times as long as your unit tests and probably your integration tests, because by nature, end-to-end and UI tests cover more parts of the system. There's a lot of setup. There's a lot of teardown. And so it just takes way longer to do those pieces. So for CI, you mostly want to be sure that you cover the small bite-sized pieces that you can test quickly to make sure that the code is actually getting where it goes. So for CI, you want to test your tests. And this is actually not something that a lot of people do. They tend to throw their tests out there. Hey, look, I'm testing the code, I'm awesome. But how good is that test? Test your environments with whatever tools are available to make sure you built what you think you built. It doesn't do any good to spend an hour automating an environment coming up when the end result is something that's just not usable, it's not representative of what you're going to have in production. You have to test everything. Test your deployment every time. There's a lot of, you see a lot of software companies, they build these test environments and they stay up and running, sometimes release after release, sprint after sprint, etc. You should be deploying every time you go through a changeover in your code. You should be able to do that with all this automation very quickly. You obviously have to go back and change and do your testing for your upgrades, but you definitely have to be able to test your new installs and make sure everything's working. And then, of course, the next one, automate your upgrades and test your upgrades. If you've got that automation in place where you can build an environment with the press of a button, there's no reason that when I go from 1.0 to 2.0, I can't say, all right, I need to do my upgrade testing. Let me kick off a 1.0 build, populate that with some, I hate to call it seed data, but populate it with some representative data of what you're looking for, and then test your 2.0 upgrade on that environment and see if it works, see if things fall out, the database didn't get upgraded, those types of things. And then you get to CD. So in CD, you actually end up at a different level than CI. You get through continuous integration, you put it into a staging environment. And the idea of the staging environment is it should absolutely mirror production. It's where you're going to want to do your user acceptance testing. You're going to build it, if you'll notice, just like you do your continuous integration environment. You're going to automate the environment, automate the deployment, do your performance testing, do your security scanning, and do your UAT. And this will let you know if you're ready to go to production. Just like every other step in here, you have to have criteria that says, if we get to staging and we find a performance problem, we have to go backwards. So I actually was a little fast there. For continuous delivery, test your performance in a real environment. It doesn't do any good to have a small representative VM with half the memory, half the CPU of what you actually are going to have in production. Test your security in a real environment, same thing. You should have the same rules for your network that you have in production. And then UAT, you want to do that as close to real production as possible so that the people that are doing the UAT can actually say, yes, this looks good. You should go ahead and push this out and release it. So that's it. I was a little fast there, but if anybody has any questions, I'll be happy to answer them.
So, maybe any questions?
So, what happens, for example, if I have 20% of application usage, that depends on user actions, like QR code, for example, and I'm talking about mobile, I need to scan something, and what can I do in that case? Should I neglect this part?
No, you can't neglect that part, and I'm not currently in the mobile space, although I was in a previous life. It's you just have to find the tools out there that are available to you. That is, as was mentioned in the keynote, there's lots of DevOps tools. I could actually probably give a whole hour presentation just talking through all the different tools for all the things you want to do. But you just have to go out there and research, and if you can't find the tool that does what you want to do, then what you need to do is find a tool that will let you change it, do the things you want to do. And I know that's not the best answer, but that's a really difficult one. If you're relying on hardware to automate your testing, you may have to set up test harnesses where you mount your phone and you have an actuator that presses the button and then feeds back to your application. There's probably endless ways you can do it, but you just have to get inventive.
I have another question then. So can I somehow create a mock for automated tests?
That mocking, yes, and actually, now that you mention it, I realize I didn't even mention mocking, but yes, mocking is a great way to try things early, especially when you're trying to integrate two pieces of a software system, say your API and your front end. You don't want the UI developers waiting on the API to happen before they do their part and they do their testing. So in this case, a mock would be a perfect way for you to at least get started with checking your code, and then you would have to rely on manual steps to supplement that.
But how do you implement this the real environment?
For mobile,
Yeah.
like I said, you're probably not going to be able to get. I don't know what tools are available, but you're probably not going to be able to get away from actually having phones and manually doing that testing at some point. You can simulate that, you can try those things and do your best all the way up to that point, but you're not going to be able to avoid it.
You mentioned also performance testing, load testing that you can include. So regarding performance regression tests, especially, can you start them early, basically by development? When developer is developing and running unit tests, can you run them there?
Absolutely. If you have all your testing automated, there's no reason, other than environment constraints, right? There's no reason you can't run those tests at any stage you want to. What I put up here is just my idea of how it works. If you think that you need to do your performance testing in your CI pipeline, that's great. How long does it take? Is it worthwhile doing at that point?
You mentioned that you need to write unit tests and afterwards the integration tests. Isn't it the word duplication?
Yes and no. There could be situations, say you upgrade your database, right? And the database actually behaves differently than maybe your mock does. That's the kind of things that you're going to have integration tests for, because you're not going to find them until you actually run the code with that code.
So I'm steering towards maybe you only need to write integration tests because we test an actual system.
But again, so say I have a method and it retrieves data from the database, and they've changed the data field type slightly so that the return is different. That's when you need an integration test. The question is, with that piece of data, what am I doing with it and what is the result from what I expect? Does that make sense? And that's why you have the unit test. Does this method actually add two numbers? Whether or not the database gives you a number or not is a different conversation.
I have a question regarding. I'm here.
Thank you.
So yeah, So if I don't have any tests, suppose, and I have a lot of code, so where should I sort of start? And I don't know how to begin, and what should be sort of manually tested at the beginning, and what should be automated, and how do you decide if you don't have any tests at all?
If you're asking me,
Yeah.
you start on the automation as quickly as possible. If you have a big stack of code and it's legacy code and there's nothing else you can do, you have these steps in place, you have QA people manually testing them, you have to keep doing those things. But at the same time, what you may want to do is slow down your development just a little bit. And every time you write some new code, you write a unit test. And every time there's a bug, you write a unit test for that bug. And you'll actually be surprised at how quickly you'll go from 0% coverage to 20 or 30%. Now that first 20 or 30% is actually, I'm not going to say easy, but it is somewhat easy. But it's that next step that's harder, and that's where you have to get into refactoring your code and actually rewriting your code in a way that it can be effectively unit tested.
So start from unit tests, and what about other tests, like sort of security, integration, performance? Do you sort of
Start small.
start
If you have enough people where you can follow some of these things in parallel, that's great. But unit testing is really your first place to start and your first line of defense against bugs in your code.
So I have a question about multitude of front ends. Currently we are experiencing problems with different devices, and these include like Windows, Nokia devices, phone devices, Samsung, and so on. So what kind of suggestion would you have for mobile testing?
I just don't know what tools are out there because I'm not in that space. I think that Android at least has some harnesses for doing testing. I believe that Apple has harnesses for doing testing. Windows, I would suspect that those would be built into Visual Studio, and you should be able to do those there, at least from a unit testing point of view. But as I mentioned earlier, with mobile, at some point, you're going to have to actually test it by hand, or if you want to build a robot that does it, however you want to do it, but at some point you've actually got to use the hardware to do the testing.
Thank you.
It's not a question, just I would like to say that there is a tool for testing on mobiles. So, for example, Amazon AWS mobile farm. So please check it. It's possible to launch like virtual devices and test on them.
Thank you.
So thank you for that great presentation. We have little presentation.